All right, good day, everyone. What we're going to be doing today is we're going to be starting to analyze and graph out sine and cosine functions. Okay, and the main goal of this is to really understand what sine and cosine represents, what is it going to tell us, and then how do we actually adjust these graphs. So eventually, we are going to talk about transformations. Okay, so the other day we talked about basically sine and cosine and the representation of both, like how are each affected, how can we work off of those, how can we build off of those, right? Well, today, we're going to kind of continue on that idea. We're really going to try to adjust our equations based off of what we see in there. Before we do that, we really have to understand sine and cosine, why they look like they do originally, and then how can we look at a sine and cosine graph and determine how it's going to look even before I really get an equation. Okay? So the first thing I really want you to understand is that sine and cosine is a periodic function. Okay? It is always going to be in a continuous value that will continuously repeat the same values eventually. Okay? On top of that fact, we always have to consider the idea that sine of theta is just going to be the same as my y coordinate for a unit circle. And the reason I bring that up is because that is a key piece to when we actually start graphing these, because it will help us describe this particular graph at its particular points. The other thing we talked about in class is how when I'm really focusing on graphing, there are coordinates I really want to focus on. For example, I want to really focus on my main values around here, okay? Basically 0, 90, 180, and 270. The reason I want to focus on those is because they give me nice values to actually graph that I can follow along based off of. For example, if I were to graph out the sine of 0, let's say I have the equation sine of theta, right? If I plug 0 in, my y value comes out to be a value of 0, okay? Because if I look at my unit circle at 0, my y value is 0. Well, if I kind of continue this around the circle, we go pi over 2 or 90 degrees. At that value, I have an answer of 1. At pi, I have an answer of 0. At 3 pi over 2, I have an answer of 1. And lastly, not least, at 2 pi, I have another answer of 0. You see how it just keeps repeating around these coordinates? Excuse me, -1 at that value. It just keeps repeating around at these coordinates, giving me a kind of nice values I can actually graph out. Well, the reason this is important is because it kind of helps describe over one period what the value of sine comes out to be. So if I were to look at this, it would start at 0. At pi over 2, it would go up to 1. At pi, it'd go back to 0. 3 pi over 2, it's at -1. And at 2 pi, it's back to 0. Giving me a function like this. That is pi over one period, okay? So just to kind of look at a couple of things, in this case, if I'm thinking about domain and range, domain technically is all real values, right? Because there's no break in the graph, it is continuous and it's a periodic function. So really, domain is all real numbers. Currently, the range is based off the amplitude. Well, if I can only go up 1 and down 1, my amplitude is only a value of 1. So my range directly is related because of that amplitude. Oops. And the fact that my range value comes out to be -1 less than or equal to y less than or equal to 1. Or it's in between those values. Last but not least, my period is always going to follow along with the unit circle. Unless it is adjusted, my period is going to be exactly what the unit circle represents, or in this case, 2 pi. Okay? Now, the other idea I really want us to think about is how pi is continuous. So this blue value is 1 period across, which is equal to 2 pi, right? Everything in blue there is exactly 1 period. However, technically, this does continue on. If I were to go down to negative pi over 2, I'd be at -1, back up to negative pi, and the graph would continue on similar to this. And on top of that, it would do the same thing over here. It would continue on with that pattern over and over again. The difference is in blue here, this is just 1 period around the unit circle. Well, everything in red there is just a continuous function as if it was going to repeat again. Okay? Now, that same idea can be applied with our cosine function. Our cosine function is going to look almost exactly the same, except it's going to start and reach similar points at different positions. For example, if you really think about cosine of x, cosine of x, cosine of theta, let's make it easier so we don't have two x's in there. Cosine of theta is our x coordinate. So if I think about those same exact values that I did on the other page, 0, pi over 2, pi, 3 pi over 2, and 2 pi, if I were to work those values out, at 0, cosine is going to be equal to 1. At pi over 2, it's 0. At pi, it's 1. At 3 pi over 2, it's 0. At 2 pi, it's 1. So if I were to graph that out, once again, over one period or one time around the unit circle, we start at 1, 0, down to negative 1. Then we reach up to 3 pi over 2 and to 2 pi. So our cosine graph looks similar to this. This is one period around the unit circle, and that's our cosine of x. But then same thing, every pi over 2, it should repeat this pattern. So for example, at 5 pi over 2, it's at 0. And then I know it's not on there, but at that 3 pi, it should be back down at negative 1. Over here, at negative pi over 2, it once again reaches 0. Negative pi, it's at negative 1. And then it comes back up to 0 here, continuing this pattern over and over again. That is a key idea that we want to bring up and understand, is that it is a constant rotation around. Now, when you look at the actual values, understand it, it's also going to be almost exactly the same. My domain, all real numbers, my range is in between negative 1 and 1. My amplitude is 1, and my period is 2 pi. Simply because if you really look at this graph, okay, the domain is always going to stay that value. There's no restrictions on x. My range is based off of how high up and down I can get, my max or my min. My amplitude describes my max or my min. I can go up 1 and down 1 from 0. And my period is going to describe basically how long it takes to repeat. So notice how cosine and sine are very similar. Really, the difference that I notice between cosine and sine is where it starts at. Okay? Cosine starts at a value of 1, which means as it goes down to 0 to negative 1 and back up, it's going to repeat a different motion. Versus the sine graph, which almost as similar, starts at 0, which it gets that up and down motion through it. Okay? Now, why is that important? Well, understanding just how cosine and sine look is going to be a lot of our problems. It's going to actually help us assess kind of how to shift it if we understand the basic idea of how it looks and why it looks like that. So now let's actually talk about a couple of shifts. So the specific thing about sine and cosine is that we can actually shift this graph based on what we see. But we have to have a basic understanding of sine and cosine. For example, if I was given this value right here, the sine of x, like in letter A, I can look at that and say, well, sine's going to start at 0. It's going to go up to 1, back to 0, down to negative 1, back to 0. So over 1 pi motion, it should look similar to that. Versus a cosine function, since it starts at 1, it goes down to 0, negative 1, 0, positive 1. So it looks similar to this. So I can have that basic understanding of sine and cosine. So now that when we actually adjust it, I can always apply those ideas to this. So let's go ahead and talk about how can we adjust sine and cosine. Well, the first manner is if I can actually change the amplitude. So in our first example here, they basically give us two different types of equations. We have g of x equals 2 sine of x, and f of x equals sine of x. Well, notice how the original one sitting here, this is our sine of x graph. Okay, it starts at 0. It goes up to positive 1, 0, down to negative 1, back to 0. So over one period, we have that value, right? Well, notice what happens when we actually shift or change this graph. if I were to take away that value and then focus on the second graph that's on there, notice how now it goes up to positive 2 over that one period. So now it's raised up to positive and negative 2. And that's a direct correlation to that value. That value is adjusting my amplitude to now reach that higher heights, the larger max and min. But the key thing I want you to look at is the comparison of the two graphs. Okay, because I think it's easy to see the difference between the maxes and the mins, but one of the key things I want you to look at is notice how it's not affecting your period. Notice how these three coordinates still reach at the same exact spot. On top of the fact your period repeats still over 2 pi once again. That value directly relates to your amplitude. That's what that 2 in front is going to affect. Okay? So let's continuously talk about how certain things are affected. If I were to scratch the graph of cosine of x plus 2, once again, the idea is how is that going to affect my graph? Well, one of the key things to understand is first off, what is cosine originally going to be? Well, cosine is originally going to be at positive 1, down to 0, down to negative 1, back up to positive 1, back up to 0, and then back up to positive 1. So one period of cosine is going to look similar to this. Well, just like how a vertical transformation can lift or bring my graph up, so can this value right here. And what it really does is it's going to lift this graph up to specific coordinates. So now instead of being at this position, this graph is going to be up here. Okay, I'm going to have a coordinate at positive 3. Instead of being at 0 for this coordinate, it's going to raise it up to be at positive 2. Instead of being at negative 1 for this coordinate, it's going to be at positive 1. So notice how it's literally dragging each of these coordinates up. So now my graph looks similar to that in blue. That is my cosine of x plus 2. And the simple fact is that it raised it up 2 units. Okay? Now that one directly relates back to our transformations. All right? And when it asks us to describe the transformation that it generates, well, we literally can state that. It drove it up 2. It translated up 2 units. So as long as we have a basic understanding of the cosine and sine graph, really all of our transformations are just adjusting what that same picture looks like. Now, we do start to see some differences. And when it starts getting a little bit different is when we start looking at a value like this. What happens when I actually shift cosine? Because typically when I look at this motion, I'm thinking left or right, which you'd be absolutely right on. But the weird thing is that it's a periodic function. So if it's repeating the same thing over and over and over again, when does it really repeat this value? Well, let's talk about this. At cosine, typically at 0, you have an answer of 1. At pi over 4, you have an answer of, I believe it's square root of 2 over 2. At pi over 2, if you go to cosine, you have an answer of 0. We'll go up to pi here, because it would be at negative 1 here. At this value, it'd be negative square root of 2 over 2. So what happens when I shift it left pi over 4? Well, the idea here I want you to think about is what's actually happening in your graph. Well, it's actually pushing your values left 1 unit. So for example, if I were to take and plug 0 in for that x, technically this would be the same as cosine of negative pi over 4, which if I plug that in the calculator or work that out, that would come out to be negative square root of 2 over 2. Ooh, did not mean to turn that. Over 2. Okay. Or excuse me, positive square root of 2 over 2, my fault. In the second portion here, if I took pi over 4 and plugged it in for x, well, pi over 4 minus pi over 4, would this value here would just become cosine of 0. Okay? So this one would be cosine of negative pi over 4. This value here would just become cosine of 0, which is, doesn't that match up with this value here? So this technically is just an answer of 1. If I continue that pattern on, pi over 2. If I were to plug pi over 2 into there, I would get cosine pi over 4. Okay? Because pi over 2 minus pi over 4 is pi over 4. That would give me an answer of square root of 2 over 2 here. If I took 3 pi over 4 and took pi over 4 away from it, then I'm at just pi over 2, which is 0. Well, look at this pattern that's going on. Literally, all of these graphs or all these numbers got shifted over a singular value. Well, this pattern actually works out across the board. And what it's literally doing is it's shifting these values over by pi over 4. Okay? So now, since this value shifted it right by pi over 4, literally every single one of these values is shifting over by pi over 4. Okay? So how would that look on a graph? Okay? So in this next question, they're literally asking, how could you shift a cosine graph by negative pi over 4? Well, once again, we are going to focus on those actual values. Let's just say in between the graph here, we make this going up by pi over 4. So we make this by pi over 4, pi over 2. This is going to be pi, 3 pi over 4. Oops. Jumped the gun there a little bit. This come out to be 3 pi over 4, and then pi, and then 5 pi over 4. Okay, and this would become 3 pi over 2, 7 pi over 4, and then 2 pi. Okay, so all I'm doing is counting up by 1/4 each time. Now, an original cosine graph would look similar to what we have here. It would start at a value of 1. At pi over 2, it would reach 0. At pi, it'd be at negative 1. So it looks similar to this. That looks really gaudy. Let me kind of fix that up. I don't really enjoy how they don't draw the actual points on the graph. Or I should say the actual pi over 4 on the graph. But that's our original cosine function, okay? And just so we can see the values, I'm not going to fully draw it in, but just so we kind of understand this, that is our cosine graph there. So what's going to physically happen after I do this transformation? Well, what it's going to do is it's going to physically move each of my coordinates over by pi over 4. So literally, I'm going to take this coordinate and move it to this position. I'm going to take this coordinate and physically move it by pi over 4 to the right. And that happens with all of these coordinates. Now, my new graph physically looks like that in red. Because what it's doing is it's moving it to the right over that value, okay? Understand now, the period still hasn't changed. It still takes 2 pi to go from start to finish here. The only difference now is that I'm starting at pi over 4 versus the original start that was at 0. So it's literally just shifting that value to the right. So when it talks about specifically, we always talk about creating parameters. Okay, what are these values going to do? And in this particular case, it says, what does parameters A, C, and D do to this graph? Because eventually we're going to have these equations of A, sine of X minus C plus D. Well, the three that we specifically talked about today is A, C, and D. And eventually, you're probably wondering, okay, there's no B in there. Well, B is going to become something we talk about that's a little bit different when we'll talk about that moving forward. But if I focus on A, C, and D, A is just the amplitude. C is going to cause my horizontal translation. Which is going to make it go left or right. And then value of D is going to make it go vertical, or our up/down motion. Now, the key when you're doing all these is just to have a basic understanding of sine and cosine. And if we have that, we can transform these graphs moving forward a lot easier, okay? But we'll be talking about phase shifts on Monday, kind of going over those. If you have any questions, please let me know. But besides that, I will see you in class tomorrow or Monday. Have a great day.